Hello guys, welcome back to the channel. In today's video, I will show you how to build a GraphQL server with Apollo server, Fastify and MongoDB. GraphQL is an open source query language for APIs and a server-side runtime for executing queries. It provides efficient and flexible way for clients to request and manipulate data from servers compared to traditional RESTful APIs. In today's video, we build a full-blown GraphQL server with Apollo server, Fastify and MongoDB, and as such, we will consider the following talking points. We are going to look at how to create strongly typed mongoose models. We are going to look at how to create queries and mutations for a GraphQL server. We are going to look at how to create resolvers for those queries and those mutations. So if you think that's a great idea, then absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification to get access to all of our videos as they drop. Make sure to leave your thoughts in the comment section on using GraphQL as opposed to using RESTful APIs for your next backend project. Let's dive into the code for today. I will run yarn init to start up a new yarn project. I don't want to use npm because npm has been compromised too many times for my comfort. This will generate a new package JSON file, and I'm going to run tsc init to generate a new tsconfig.json file. Then I'll replace the contents of that file with a default config I've already copied. I will run yarn add Apollo server to install Apollo server. Then I'll also run yarn add Fastify, mongoose, and add as-integration/Fastify to install these dependencies. These dependencies are all we are going to be needing for this project. After they are done being installed, I will create an src folder, and inside of that folder I will create an index.ts file. The first step is to attempt to create a basic Fastify server, and as such, inside of this file I will import Fastify from Fastify. Next, I will create a new async function start server, and inside of this function I will add a try catch block. Inside the try block I will create a Fastify object by calling the Fastify function. Then I will subsequently listen on port 4000 to start the server, logging out a message to the console to confirm that the server is up and running on port 4000. Inside the catch block, I will call fastify.log.error with any error encountered while trying to start up the server. I will use nodemon to serve up this app, and you can see that we get a message in our console, server running on port 4000. The next step would be to connect to our MongoDB database using mongoose, and for that I will import connect from mongoose, and then I will create a db_url variable. This is equal to the URL for my local MongoDB database community edition. Inside the start server function, I will await a call to the connect function with the db_url, and then I will console log a message, database connection successful. Running this app from the terminal again, and you can see that the database connection is successful. In my most recent video on mongoose and MongoDB, I showed you how to get started using MongoDB with mongoose, and in case you missed that, you can go ahead and watch it and come back onto this one when you're done. In this video, we are going to create strongly typed mongoose models, and for that we first need to create the types file. I will create a types.ts file, and inside this file I will import documents from mongoose. I will also import object id from MongoDB. Then I will create an interface book document which I will export from this file. This interface will extend the document which can be imported from mongoose, and on this interface I will define an underscore id property which will be of type object id. It will also have a title property which will be a string, an isbn property which will be a string. It will have a page property which will be a number, and is published property which will be a string, a created alt property which will be a string, and an updated alt property which will also be a string. I will define and export another interface author document which also extends from the document interface. It will have an underscore id property which is of type object id, a name property which is a string, and an email property which is also a string. Now let's define the schema, starting with the author schema. I will create a new file author.ts which sits inside of a schema folder which sits inside of a data folder. Inside this file I will import the author document from the types file. I will also import schema from mongoose. Next I will create an author schema, and this schema is going to be a much more complex schema as opposed to the schema we created in the last video. This schema will have error messages for handling field validation. First of all, the schema will have a name property which is required, and a required property is going to be an array in this instance. This time the first value is going to be true, and then a string is going to be the next value which reads please provide the name of the author. This is in case we try to create an author without providing the name property, we are going to get this error message, please provide the name of the author. The next is to define the type of this name property which will be a string. The author schema will also have an email property which will be required. The required property will also be an array with the first value value being true and the second value being a string, please provide the email of the author. The type will be a string and the email property will have a unique property which is an array. The first value will be true and then the second value will be a string author with that email already exists. This ensures that no two author documents have the same email. I will add a trim property which will be set to true, and this trims off any leading spaces in the email string when we try to create a new author with an email and a name. I will set the lowercase property to true, and this ensures that the email string is saved as lowercase values. I will also add a validate property whose value will be an array. This first value inside this array will be a function which accepts an argument v, which is a string. This v is going to be the password string, and then I will return a validation check where I use an email regular expression pattern to validate the email string. This ensures that all author documents have a valid email. If the validation fails, I will add a string which reads, please provide a valid email address. Next, I'm going to export this author schema as default from this file, and then I will create a new file, book.ts, inside the data/schema folder. Inside this file, I will import the book documents from the types.ts file and will also import schema from mongoose. Then I will create a book schema by instantiating the schema class, and I will strongly type the book schema to be of book document. On the schema, I will add a title property which will be a required property. It will be an array and the first value will be true. The second value will be provide the title of the book. The type of the title will be a string, and I will add a min property which defines the minimum number of characters allowed for this title. This will be an array and first value will be 3, while the second value will be a string. Title must be at least 3 characters. Next, I will define a max property which controls the maximum number of characters allowed on the title. It will also be an array and the first value will be the actual number of characters, which is 100, and the second value is going to be a string which reads title must not exceed 100 characters. In this case, anytime we try to create a book whose title is more than 100 characters, it is going to fail and we are going to have this validation message. Next, I'll add a pages property which will be required. Its type will be a number. I'll also add an ISBN property which will be required. Its type will be a string and it is going to be unique to ensure that no two book documents have the same ISBN property. I will set the index property to true, and this creates an index for the ISBN property for the books collection. I will add an isPublish property which will have a default value of true, and its type is going to be a boolean. The default property ensures that all documents created from this schema will have an isPublish property that is set to true, whether or not we define it on the document when we are creating it, except of course we set the isPublish property to false when we are creating a document. Then the book will have an isPublish property which is false. The schema will also have an author property which will be equal to the author schema. Then I will add a timestamp property on the config object to ensure that we get the updated art and created art on every single book document. I will export this book schema as default from this file. To create strongly typed mongoose models, we need to head back to the types.ts file to create an interface for the book model. This will allow us to get autocomplete for custom methods which will be added to the book's model later. However, I will not do that. This is just to show you how to create strongly typed mongoose models. I will create an export and interface book model which extends from the model interface which can be imported from mongoose. I will use the book document to strongly type the model, and on the interface I will define a find books by author method which will accept an underscore id argument which is a string, and it will return a promise which resolves to an array of book documents. I will also add a find book by ISBN method which will accept an ISBN argument, and it will return a promise that will resolve into a single book document. I will add another method, filter books by pages, which will accept a pages argument which will be a number. It will also accept a second argument, filter, which will be a union of a narrow string. I will create and export a variable book underscore pages underscore filter which contains two values, less than and greater than. Then I will use this as a narrow type for the filter operator. This method will return a promise that will resolve into an array of book documents. Now let's create the models that allow us to manipulate documents in the collection. I will create a new file, author.ts. This file is going to sit inside the model folder that sits inside of the data folder. Inside of this author.ts file, I will import model from mongoose, and I'll also import the author document from the types.ts file. I will import the author schema and use that to create an author's model. I will use the author document to strongly type this model, and I will export this author's model as default from this file. I will create another file, book.ts, inside the models folder, and inside this file I will import the book document, the book model. I will also import the book schema, and I'll also import model from mongoose into this file. I will create a books model with the book schema. I will strongly type this books model with the book document and the book model. Then I will export the books model as default from this file. If you like what you're seeing, please support the channel by smashing the like button. Ensure you subscribe to the channel and turn on the bell notification so you don't miss any of our videos as they drop. Now let's open up the index.ts file to add the type definitions for the GraphQL server. The type definitions allow us to define the shape of data on the GraphQL server. You can create an object using the type keyword, and as such, I will create a book type which we have an underscore ID property, book type with B and ID. This is a primitive GraphQL type that represents a unique ID. The book document will have a title property which will be a string, a page property which will be a number, and its published property which will be a boolean, a created art property which will be a string, and an updated art property which will also be a string. I will add an author type which will represent an author object. It will have an underscore ID property, a name property, and an email property. The book type will have an author property which type will be the author type. We need to define a query next. The query type is what defines the type of data we can fetch from the GraphQL server. This is how we make read requests to the GraphQL server, and as such, I will add a books query which will resolve to an array of books. The exclamation mark ensures that there must be an array, and the array cannot contain any null values for a book object. I will add a book query which accepts an ID argument which is of type ID, and it will resolve to a book object. I will add an authors query which resolves to an array of author objects, and I also add an author query that accepts an ID argument which resolves to an author object. Notice that we can define a query that looks like a function type definition in Typescript. This allows us to pass parameters to the server, much like how we can pass query parameters or root parameters to a normal REST server. Next, we need to define a mutation type. This mutation type is how we make changes /update /write requests to the server. I will pause first so I can define the shape of data we can pass to each mutation. I will define an input, book input, and this is how we define a mutation parameter object. The book input will have a title property, an author property which will be an ID type, an ISBN property, and a pages property. Next, I will define an author input. It will have a name property which cannot be null and an email property. I will create a new file inside the src folder named resolver.cs, and inside of this file I will import the book models, the author model, and I will create and export a variable resolver. This is an object that Apollo server will use to provide the data and the functions for fetching the data for our queries and for handling the mutations. Okay, on the object I will add a query object which will be an object, and on it I will resolve the books query first. Take note that when resolving a query object, you can basically use anything as far as its end product will be an object that matches the shape of the return type. Okay, I will use a function in this instance. However, you can use an object if that's what you wish. Since I am using a function, the function must return an object that matches the shape of the book type we defined in the type definitions. This will be an asynchronous function, and inside this function I will use the find method on the books model to return all books in the book collection. Next, I will add a book property on the query object which will also be equal to an async function. All arguments passed to query object lives on the second argument anytime we are using a function, because by default this function will be called with some parameters. Okay, I will extract the ID argument from the second argument, right, and I will use that to find a book whose ID matches the ID argument and return it from the function. I will resolve the authors query using the find method on the authors model to return all authors, and then I will resolve the author query using the ID passed in to find the author whose ID matches the ID argument. I will head back to the index.ts file to continue with the mutation type, and I will add an add book mutation which accepts a book argument. This will be of type book input, and it will return a book object. I will also add an add author mutation, and this accepts an author argument which is of type author input, and it returns an author object. I will head back to the resolver file where I will add a mutation property, and on it I will add an add book property. I will extract the book parameter from the second argument, and I will attempt to fetch an author using the book.author property. If the author exists, then I will create a new book, setting the author of the book to be equal to the found author object and returning the created book from the function. However, if the author does not exist, I will throw an error, author not found. I will add an add author property where I will extract the author's argument from the second parameter this function is going to be called with, and then I'll use it to create and return a new author. I will head back to the index.cs file and I will scroll to the start server function, where I will create a new variable Apollo, which will be equal to the result of creating a new Apollo server. This constructor accepts an object as its argument, and this object will have a type depth property which will be equal to the type definitions we created for this GraphQL server. It will have a resolver property which will be equal to the resolver's object, which can be imported from the resolver.cs file. It will also have a plugin property which will be an array, and inside of this array I will add a Fastify Apollo Dream plugin. This is a function and I will call it passing in the Fastify object as an argument to it. I will call the register method on the Fastify object, passing in a call to the Fastify Apollo method, while passing in the Apollo server as an argument to this Fastify Apollo method. You can see that our GraphQL server is now up and running, and if I visit localhost port 4004/GraphQL inside of our browser, I will try to add an author first with the name of Lionel Messi, and I'm passing a invalid email as the email property for this author. I will try to get the ID property and the name property from return value, and you observe that we get an error because of the email validation phase. Remember, when we are creating the schema, we added a validation for the email property for the author schema. You can observe that we get a custom error message. Please provide a valid email. I will add a valid email address lionel@gmail.com, and you can see that we get any author with the underscore ID, name, and email property. I will create a new book with the title My Time at Baka. The pages will be 300 and the ISBN will be 12345678990T, and the author property will be the ID of the newly created Lionel Messi author. We have an error. This is because the pages property is incorrectly set to a string. So let me sort that out and test again. I can see that we get the created book in the result tab. If I fetch authors, you will see that we get one with the name Lionel Messi. If I try to fetch a book by its ID, you see that we get the latest created book. If I also try to fetch an author with its ID, you can see that we get the Lionel Messi author we just created. So that's going to be it for this video, guys. I hope you found it useful and interesting. If you want to see me do a more advanced GraphQL tutorial, then make sure to do so using the comment section. Don't forget to smash the like button and ensure you subscribe to the channel and turn on the bell notification, and I will see you in the next one.